Have you ever considered the possibility that you are really the only person in the universe? Or perhaps you've wondered whether there is anything else to our existence beyond our perception of it. In the end, could the James Webb Telescope demonstrate that we are residing within a black hole? Join us as we investigate this baffling possibility, one that could make you reconsider everything you believed you knew about the universe. So, what exactly are black holes? They are similar to something out of a nightmare. You may have heard about them in science fiction films, but in reality, they are even more terrifying. Scientists describe black holes as regions of space where enormous amounts of matter are compressed into an incredibly small area. Imagine a star much larger than the Sun, compressed into a space the size of New York City. The gravitational pull is so intense that not even light can escape. For years, scientists have been captivated by black holes. These space objects are so massive and dense that they block light, making them difficult to detect. However, researchers have discovered ways to infer their presence by observing their effects on nearby objects. For example, when a cloud of interstellar matter passes near a black hole, it gets pulled toward it in a process known as accretion. When a normal star gets too close, it can be torn apart, releasing X-rays in the process. Black holes can also have significant effects on their surroundings. They can consume material from nearby stars, release powerful gas blasts, and even influence the formation of new stars, either speeding up or slowing down their development. But how do black holes form? Stars that were once magnificent meet their fate in a massive explosion called a supernova. From the ashes of these shattered giants, black holes emerge. Most black holes are formed by massive stars that have reached the end of their life cycle. When smaller stars die, they become neutron stars, extremely dense, but not dense enough to trap light. However, if a star is several times larger than our Sun, it collapses under its own weight, forming a powerful black hole. Time behaves strangely near black holes. To an observer far away, time seems to slow down as you approach the event horizon, the point of no return. If two smaller black holes merge, they form a significantly larger and more dangerous black hole. When a neutron star interacts with a black hole, it creates an even more extreme cosmic phenomenon. For a long time, scientists classified black holes into two main types: stellar mass black holes and supermassive black holes. The latter, which reside at the centers of galaxies, can be millions or even billions of times more massive than our Sun. In our own Milky Way, a supermassive black hole lurks at the center, pulling everything around it toward its immense gravitational field. The renowned physicist Stephen Hawking dedicated much of his life to studying black holes. Some of his theories couldn't be tested due to technological limitations, but hope remains. A single scientific instrument may revolutionize our understanding: the James Webb Space Telescope, JWST. Unlike any previous telescope, the JWST is an engineering marvel and a testament to human ingenuity. While earlier space telescopes, such as Hubble, provided incredible insights into the universe, the JWST goes even further. Costing $10 billion and requiring collaboration between NASA, the European Space Agency, the Canadian Space Agency, and over 300 institutions, the JWST is pushing the boundaries of space exploration. Following its successful launch, NASA announced that the JWST has enough fuel to operate for more than twice its originally planned mission duration. The telescope traveled over 1 million miles to its orbit around the Sun, where it will remain indefinitely. One of its most exciting moments came when it captured its first starlight images. One of the JWST's key missions is to investigate the early universe, including the Big Bang and the epoch of reionization, the period when the first stars formed and ionized hydrogen gas. The telescope's powerful sensors will also help locate and study exoplanets, revealing details about their atmospheres and whether they could support life. Beyond studying planets and galaxies, the JWST may help answer one of humanity's greatest questions: are we alone in the universe? Or, even more profoundly, are we actually living inside a black hole? Recent discoveries by the JWST have already begun to raise fascinating possibilities. Scientists have found polycyclic aromatic hydrocarbons, PAHs, around massive black holes in distant galaxies. These carbon-based molecules, which also exist in our own solar system, could be the building blocks of life. Astrophysicist Ismail Garcia Bernard from Oxford University studied 3 active galaxies, NGC 6552, NGC 70319, and Stephan's Quintet, located millions of light-years away. His research found that intense radiation from supermassive black holes altered PAH molecules, changing their structure in ways that could impact how life forms. This raises profound questions: are we truly alive, or do we only think we exist? Could it be possible that our entire universe is inside a black hole? As the JWST continues its mission, it challenges our understanding of existence. It is not just a telescope, it is a key to unlocking the universe's deepest secrets. Its discoveries may not only shed light on black holes and exoplanets but also reshape our understanding of space, time, and even gravity itself. The more we learn about black holes, the more we may realize how interconnected everything is. Could we be part of a larger cosmic story, one that the JWST is slowly unraveling? And with each answer, new questions arise. Are we part of a grand cosmic experiment? Or is our existence tied to dimensions we have yet to comprehend? As we journey further into the unknown, the JWST leads the way. It holds the potential to redefine space exploration, confront dark energy, and uncover the true nature of gravity. With each new revelation, we move closer to answering the ultimate question: what is our place in the universe? As the James Webb Space Telescope, JWST, continues its mission, each new discovery brings us closer to understanding the mysteries of our existence. While scientists have long theorized about black holes, dark matter, and the structure of the cosmos, the JWST is now providing direct observations that challenge our current understanding of reality itself. One of the most intriguing aspects of the JWST's research is its ability to peer back in time, capturing images of galaxies that formed billions of years ago. These glimpses into the past allow researchers to study the earliest moments of the universe's existence, shedding light on how matter and energy shaped the cosmic structures we see today. But what if these observations lead us to an even deeper realization, one that suggests our very perception of reality is incomplete? Some physicists propose that black holes may not just be destructive voids but could serve as gateways to other dimensions or even entire universes. If this is true, then the very fabric of space-time may be far more complex than we have ever imagined. Could it be that what we perceive as our universe is merely the interior of a massive black hole? And if so, what lies beyond the event horizon? The JWST's ability to analyze distant exoplanets is another key factor in this search for answers. By studying their atmospheres and chemical compositions, scientists hope to find signatures of biological activity, potential signs of extraterrestrial life. If we discover life beyond Earth, it could revolutionize our understanding of biology, evolution, and perhaps even the origins of life itself. However, the telescope's findings are also leading to more philosophical questions. What if life in the universe is far rarer than we thought? What if we truly are alone? Or conversely, what if the universe is teeming with life, but we lack the ability to perceive it due to the limitations of our senses and technology? As the JWST delves deeper into these mysteries, it is not just expanding our scientific knowledge, it is redefining our place in the cosmos. The possibility that we are living inside a black hole, or that the universe itself is a simulation, remains speculative. But with each new discovery, we are forced to confront the limits of human understanding. The telescope's mission is far from over. In the coming years, it will continue to push the boundaries of what is observable, testing theories that were once confined to the realm of speculation. Will it ultimately prove that our universe is a closed system, or will it unveil new pathways to understanding dimensions beyond our own? One thing is certain: the more we learn, the more we realize how much remains unknown. The JWST may not just be a tool for exploring space, it may be a key to unlocking the deepest truths about reality itself. The possibility that, with the help of this amazing instrument, humanity might finally discover the responses to inquiries that have eluded us for millennia is exciting. Now, as new discoveries are made, one thing is clear: the James Webb Space Telescope is a manifestation of the human desire to comprehend our universe and our unwavering interest in understanding the unknown. It is not simply a project, it is a representation of who we are as a species. We are looking toward the stars, not only for answers but also for comprehension. The mission of the James Webb Space Telescope, JWST, is being carried out, and it promises to alter our understanding of the universe in ways we cannot yet imagine. The capability of the JWST to peer into the very beginning of the universe is groundbreaking. Additionally, the telescope is intended to respond to some of the most fundamental inquiries concerning the nature of space, time, and existence itself. The information it uncovers may not only alter our methods of observing distant galaxies and stars, but could also challenge some of the fundamentals of physics and cosmology. Scientists are very interested in the mysterious study of dark energy, the force that drives the accelerated expansion of the universe. Galaxies have been observed by astronomers to be escaping us more quickly, but they don't fully understand why. It is believed that dark energy is responsible for this occurrence, but it remains one of the greatest unanswered questions in modern science. The JWST is ideally suited for studying dark energy because it is capable of observing the universe at unprecedented depths and distances. By studying how galaxies are spread out and the ways in which they move, researchers hope to learn something new about this mysterious force and how it affects the universe in other ways. The intriguing possibility is that the JWST could assist us in answering one of the most fundamental inquiries regarding how life begins. By studying the environments of exoplanets in greater depth, the telescope can offer important information about the conditions required for life to exist. For instance, scientists are interested in locating indicators of habitability, such as the presence of an oxygen-filled atmosphere, liquid water, or compounds related to biological activity. These distant worlds could change the way we think about life in the universe, suggesting that life may not be as isolated as we once believed. Additionally, the JWST could provide information regarding the formation of life in the universe as a whole by looking at life's molecular building blocks, such as amino acids and other vital chemicals. The telescope may provide fresh perspectives on the processes that resulted in the evolution of life on Earth. The findings could lead to an entirely new area of astrobiology, where researchers investigate how alien worlds might support life under conditions similar to ours. In addition to studying star formation, planetary systems, galaxies, and stars, the JWST will also concentrate on the death of stars. Stellar formation and the death of stars, such as neutron stars and white dwarfs, is frequently a violent and dramatic process characterized by supernova explosions. These explosions unleash a great deal of energy into space and may start the formation of new stars and elements that enhance the interstellar medium, which contains life-sustaining materials. By looking at the traces of these explosive events, the JWST can provide useful insights into the stages of stellar evolution. The telescope's aptitude for studying the development of galaxies is another important aspect of its mission. Galaxies, like living things, go through developmental stages of birth and death, and the capabilities of the JWST give it access to the cores of these enormous structures. It can observe galaxies as they were billions of years ago, demonstrating their evolution. This kind of data will not only assist us in comprehending the past of the Milky Way, our own galaxy, but also how other galaxies developed. By comparing these distant galaxies from long ago to the ones we see today, scientists hope to discover the processes that control the formation of new galaxies and their interactions. In fact, the JWST will also provide a glimpse of what's to come. One of the most fascinating aspects of the JWST is its capacity for in-depth observation into the future of our galaxy. As the Milky Way develops, it will eventually collide with the Andromeda Galaxy, an occurrence that will alter both galaxies. The first observations of other galaxies going through similar mergers will help scientists predict how these cosmic collisions will unfold. During this time, our galaxy may change. Cosmic collisions remain inevitable, but with the JWST's technological marvels, scientists will gain a better understanding of these events. The end result may be philosophical. The more the telescope learns about the vastness of time and space, the more it will undoubtedly prompt fresh discussions about the nature of existence. Questions regarding the possibility of the universe's origin, existence on other planets, and the fundamental structure of reality will emerge. The urgency and significance of these questions could reshape our understanding of the universe. As the JWST continues to send back images and data, humanity will gain access to some of the most groundbreaking discoveries ever made in the quest to understand the universe. One thing is certain: as we get closer to the answers to some of science's longest-standing mysteries, the telescope will remain a powerful lens through which we explore the cosmos. The more we learn, one thing will remain constant: humanity's thirst for knowledge is unquenchable. The James Webb Space Telescope serves as a lighthouse for this unending curiosity and will continue to lead us as we investigate the universe for many years to come. As the James Webb Space Telescope, JWST, continues its mission, its discoveries will not only deepen our understanding of the universe but also challenge our fundamental beliefs about existence, life, and the very nature of reality. With each new image and piece of data, the telescope will shed light on distant corners of space-time that were previously inaccessible, opening up entirely new fields of inquiry for future generations of scientists. In addition to its contributions to our knowledge of cosmic phenomena, the JWST will likely serve as a catalyst for new technologies and innovations. As scientists push the boundaries of what is possible in space exploration, the advancements made through the development and operation of the JWST could have far-reaching implications for other fields, such as medicine, materials science, and artificial intelligence. The tools and techniques developed to study the universe could one day improve life on Earth in ways we can't yet foresee. Furthermore, the JWST will likely inspire the next generation of scientists, engineers, and explorers. The incredible images and discoveries it provides will capture the imagination of people around the world, fueling a new wave of curiosity and enthusiasm for space exploration. By making these discoveries public, the JWST will not only engage the scientific community but also encourage a broader cultural understanding of our place in the universe. It will foster a sense of global unity, as people from all corners of the Earth share in the awe and wonder of the cosmos. The insights gleaned from the JWST will also provide us with a deeper appreciation for the fragility and interconnectedness of life on our own planet. As we peer into the distant past, studying galaxies and stars as they were billions of years ago, we are reminded of the vast scale of the universe and the preciousness of our existence. This realization could inspire greater efforts to protect and preserve the Earth, recognizing that our planet is not just a unique oasis in the cosmos but also a rare and fragile environment that we must safeguard for future generations. In conclusion, the James Webb Space Telescope is much more than just a scientific instrument. It is a symbol of humanity's unyielding quest for knowledge, a reflection of our desire to understand the universe and our place within it. As it continues to unravel the mysteries of space, the JWST will not only redefine our understanding of the cosmos but also challenge us to think deeply about our own existence, our future, and the legacy we leave behind. Through its groundbreaking discoveries, the JWST will continue to inspire and transform humanity's view of the universe for years to come.